Today's lesson is a building construction and drawing. So they are the factors that influence a house or construction. When you design a house, those are the factors influencing the climate, soil condition, local state, other building regulation, environmental, heritage awareness, and the government issue. Here is a building type. This building is a timber frame construction. So here is a veneer construction type. There will be a brick veneer, and this is a cavity bricks construction method. So here is the methods of frame building. So all the method by, and we build a building like this. This is a construction of the house. This is a roof, ceiling, wall, floor, and base structure, and the flooring. So those are the components of the building. So when we are doing the components, firstly we do the foundation. The foundations are the actual ground which the building is constructed. So that will be the ground preparations. Firstly, we need to do the leveling, trenching, and the backfillings are important. The footing is need to be erected. The part of the construction that's for the load of the house in the soil is the footing. So this is the back footing. So this is the isolated bias, and this is a strip footing. This footing are reinforced the concrete pour around the building as a base for the external wall. So this is a concrete footing, and this is a concrete slab footing. So we also have to do that. This is for the footing. We erect the footing on the ground. So this is the base of the floor structure. This floor structure is a continuous masonry wall, brick layer, concrete slab. So this is the construction building floor frame and the footing. So this is the dam floor. Dam floor is we have to protect this any oil or moisture coming in the building. We have to use the dam floor. So this is the water resistant sheet. This is subfloor structure. This is the anchor are also instructed. The function is to help and prevent the damping while entering the floor structure. If dam floor goes and the end cap are the place, the dams are goes are prevent moisture raising up the wall. The floor can be the timber board, concrete slab, rug, screen, and a smooth surface. Wall can be that this is the wall, this is the surface, roof, and this is the load bearing. Load bearing walls are transfer the load to the foundation, support the weight of the roof. No loads are bearing walls are the partition wall. Do not carry the load and divide the space in the partition. This is the function of the building construction. So here we see there's a brick veneer wall. This diagram is a brick veneer wall. The brick outer skin, there's a floor joist, and the wall brace and the studs are constructed. So this will be the outside inside hole, and this is the cavity. That cavity is between the inner and the outside layer of the skin. The function to prevent the transfer of moisture, allow the movement between the timber frame and the brick wall. Brick veneer wall complete the construction diagram. So you have to see the wall hole and bring out the sheet. And also that we have to know the technical tasks and their location in the diagram. Here will be the cavities are wall construction. So there will be the outside brick wall, inside brick wall. This is that we have to use a wall tie. There's a wall tie. So this is that we also use a dam course. And this is the wall ties how we constructed. And here is a low bed wall. The function of the low wall cavity is it provides a moisture barrier, air circulation, thermal, acoustic insulation. So here from this cavity wall, we can run the cable in the cavity and then we connect it to the socket outlet. Then here we can see the roof construction. Construction of the roof. Roof construction is this is the supporting frame. So this is a roof covering. Roof covering are the 5 ties of the sheet metal. They supporting the timber frame wall. The tie of the roof structure determine the ease of the access for the wiring. So roof frame is a conventional roof frame. This is a diagram you can see on the wall book, and also the technical time and location. So this is the truss roof construction. Truss roof, this is the best. This is the top core and they are neighboring, and here is the bottom core. Here is one member and supporting the wall pattern. So this is the truss roof construction. So this is our construction step. First, we have to set out provision for the underground wiring and the data supply. Then we have to use do the footing, base, floor, wall, roof, and the cladding. So this is the brick layer. This one is we have to provide a brick layer. This is the underfloor cable, And also after that, all the steps we have to electrician have to take part. After the interior lining, rush in, tiling, and in this tilers have to take part, and a painting, and a final finishing. Finishing is a final fit out. So the whole this step plumber have to take part. So this is the step of the building construction. So there are the question and answer. You do the question and answer. Then the six main parts of the structure. So those questions you have to answer. This is a question. So there is a construction diagram of the building. So there will be this diagram is a construction diagram of wall and a cavity wall and plate, joist, floors, and brick barrier construction. Here we say construction of the timber frame, bedding plate, temporal, case, reinforcement. So it includes timber frame, metal frame construction. So it also includes water, weatherboard, bridge, tie sheet, treated metal, fiber basement, plywood, hardwood, PVC, sheeting. Those are the construction of the metal frame construction. This is the electrical cabling, how the electrical cabling runs, and it is a component of the building. Here is a rope construction, rope covering, supporting framework. This is a truss ropes are construction. So this is how the truss ropes are constructed. And here is we can also read as a building construction terminology. So this is a building construction terminology, or this is technical term, and this is the indication of the building component. Another thing is that we also have to talk about the fire resistant wiring system. Fire resistant wiring system is we provide a heat resistant, fire resistant, and a heat and a fire resistant. So we use a MIMS cable, magnetic insulated metal sheeted cable. This is a more difficult to install. It utilizes and maintain the circuit during the fire, and the breakout is prevent the breaking out of the fire plant, emergency lighting ban. So this is a termination method. We have to utilize a special tools. In this case, we use the protonus sheet master. This is a tool to strip off the metal sheet. So this is a stripping tool for the MIMS cable. Here is a spanner to hold as our MIMS cable and grid the cable in a rotation. It cut off the metal sheet. The end of the cable should be square to the begin. Use the 5 tools hacksaw inside the cable and the tighten notch to allow the tool to rotate on the cable. Adjust the blade position. It should be set in halfway between the sheet and the conductors. Hold the cable with the plier of the multi grips. Rotate the tools clockwise up to plier to achieve the square end. This is the function of the metal grip. Here is we also utilize the stripping rod. Stripping rods are fit and the stock to take the sheet, live with the side cutter at the angle 45 degrees with the rod, while the twisting around the cable. Here is the side cutter. We have to cut the chip, cut with the hacksaw, strip the cable, clean the conductor, and this is the screw on the sheet, and attach the cable to remove the excess powder and assemble the stuck gap and the compress the compound. So this is how to use the stuck gap and clean the ball. This is the process to do this cutting of the MIMS cable. So here is the component we use as a side cutter method, and also those are also the termination. So in this case, we have to utilize we have to test the continuity of the MIMS cable. We have to see the diagram based on 18 section of the G106 workbook. And conductor side can be the 7 stand and 1 millimeter square to the 1.25 millimeter square across the area. EI is a sheet reductance system. So we have to combine the neutral and the adding conductor. So we have to use a cross 3Y system on the AS 3000. We provide a spoke facing. The spacing between the facing and spoke for the MIMS cable should be such to protect the cable from the sagging, tacking, and the split MIMS cable from the TBS cable and the PVC conduit at least 25 millimeter. We had to utilize a termination method, use a specialized tool Insulation resistance is at least 100 mega ohm. Wire removal also be important. Wire must be removed before the cable is seen, as this will affect the insulation resistance. Insulation can be the magnesium outside. So the melting point is a 2800 degrees centigrade. Fire's performance test has been conducted across with the BSC381, BSEN 50200, BS849, IEC6033. So in this case, the melting point is inside does not produce a toxic gas, also important. Safety testing, we have to apply the AN3000 across 8 by 3 by 5, 8 by 3 by 6, 8 by 3 by 7, 8 by 3 by 8, 8 by 3 by 9, 8 by 3 by 10, and the 2 by 9 by 5. Those are the safety testing. We have to refer that those are AN3000 standard. Then here is a construction foundation of this diagram. The early neutral link. This is 80 ampere main switch, RCD, and this is active neutral and arc connection. And here is a disconnection connected to the LiDAR. So this connection. So this is for the supply wire, and the supply main, and also the load. This is the live wire switch, and the neutral link, the connection diagram. Those things are there. You have to do the practical exercise. And another lesson. We're talking about the steel wire armor cable. So this is the ground. If you use the SW cable, we get placed under the ground. Steel wire armor cable SW are the sometimes used as the alternative to the wiring system in a PVC conduit where the mechanical protection required. These methods are generally more expensive than the TPI cable in a conduit. They are generally quicker to install. So this is the PVC fitting, a PVC sheet. This is a conductor sheet, and this is the armor. How to do this? To get the steel wire armor cable, we have to use a hacksaw. And then to join the steel wire armor cable gland has to be utilized. Armor cables have the advantage of the metallic wrapping that surround the core of the cable with the wrapping itself are being protected by the PVC sheet. So this is as a construction term. The metal armor is a mechanical protection, not a conductor. So this armor can be used as an artist. So here is a conductor, here metal armor and connected to the arm. The fitting of the cables are gland used with this side of the cable must be capable of the making option as an electrical connection to the steel wire armor. Some gland will be also made the weatherproof, see with the sheet of the cable. The extra protection offered by the steel wire armor let the cable to install, especially in a situation that might otherwise need the protection of the conduit. So here is a cable gland construction. They use for the connecting the SVA cable. This is junction box, cable gland, and the lamp holder base, and this is SVA cable. So this is the construction and the connection of the SVA cable. So that we also utilize the interconnection between the SVA cable and the equipment. So in this case, it includes the thread. Plus gland can be the A2 is an armor cable, B2 is an armor cable, the gland, CA is for the braided cable, CH3 is all type of the skin, CW the steel wire armor cable with the outdoors installation. We also utilize a nickel braided gland is a HMS, so IBCC is a rated waterproof. Also the Hamas EMC water ties application is also included. Nylon gland are also utilized hormones of BA, IBCC8, weather type, and the dust type. Those are the kind of the hammer cable. We have to support that SVA cable. The cable must be sufficient support to prevent the undue stress when the SVA is run vertically. The support need to be closer than the armor cable because the armor cable is much heavier than the armor cable. So we use as a installation requirement. To install the steel wire armor cable, we follow the class 1 by 4 by 18, 3 by 9 by 7 by 2, 3 by 9 by 6, 5 by 3 by 2 by 2, and 5 by 5.3.2. This is the installation requirement. We follow the Austrian standard. And the safety testing, AS3000 standard we have to follow. Safety testing is the other system is a safer, sufficiently low. In this case, we have to utilize the 8.3.5. The clause and the insulation resistance is a safe and sufficiently high. So 8.3.6. Correct polarity, we follow the Austrian standard 8.3.7. No transportation of the iron neutral 8.3.8. But the verification of the alloy resistance is a 8.3.9. RCD operation 8.3.10. Or the circuit control protection 2.9.5. Those are the we have to follow those standards. After that, we have to do the question answer. How is the steel wire armor cable defined as 1/4/32 is a cable provided with a rubbing or the metal usually takes or the wire primarily for the purpose of the mechanical protection. If the steels are armoring steels wire armor cable needs to be added, where should it be added? So in this case, at the conducting sheet, armor and the skin on the cable. So we follow the 5.3/2/1. So this is for the connection of the steel wire armor cable. They are SBA cable construction. So this is SBA cable and the connection to the line. This is installation of the light holder, metal classway, and also construction of the SBA cable. Can the SBA cable install directly in the concrete slab without any further protection? Yes, because we follow the table 3/1 AS3000. And what is the minimum depth in the ground of the steel wire armor cable installed underground? So in this case, 300 millimeter, table 3/6 of the AS3000. It is permissible to install the SBA cable buried direct in the ground without any further protection. Yes, the clause of 3/11.3. What is the minimum bending radius for the 25 square millimeter 4-core SBA cable overall diameter 30 meters? So in this case, we have to use the 360 millimeter. The formula is 12D, so 12 by 130, so that is 360 millimeter. So we have to follow the 3/10/3/4. And armor cable, bending radius is 6 times cable diameter. Armor cable, the bending radius is 12 times cable diameter. So this is the cable diameter, this is bending radius. The relationship, those formula have to be utilized. The next one is when joining the SBA cable in the steel armoring, what are the requirements for the armoring? So in this case, we follow the 3/10/3/3 continuously. Continuity or important mechanical, electrical continuity of the conducting enclosure shall be maintained. Number 8 is when the installing SBA cable on the vertical wall, what can be used to face the cable to the wall? So in this case, the cable spoke shall be provided at the interval not exceeding 8 meters or the as recommended by the cable manufacturer. So we follow the 3/9/5. So here is a one click to another click. The distance is 8 meter maximum. So we have to follow the 3/9.3 supporting facing. They must be complete with the 3/3/2/8. Wiring system shall be fixed in a position by the suitable clip, settled or clamped by means that will not damage the wiring system. So the final means what is the maximum operating temperature? B75 PVC sheeted cable. So 75 degrees centigrade, table 3/2. Another thing is installation requirement. So here is a construction of the catenary wire. So this is catenary wire construction. So here will be the catenary wire clamp, chain, trailing cable, canaries are construction. So this canary wire clamp is here. You can see that this diagram. So this is a component of the canary wire clamp, canary wire construction. Here you can see there's a here is canary, and this is for the chain. So that the canary wire construction like this. The next one is E lesson 15. So this is the MIMS cable. Minor insulated sheeted cable. Minor insulated sheeted cable consists of a similar copper sheet. What powder insulation? We use a copper conductor. We are servicing magnesium outside insulation utilized. How is the MIMS cable defined for the AS3000 wiring? Those 3/9/7/3 is the type of the cable insert consists of the and these are seamless metal sheet housing a tightly compressed material outside water powders or magnesium outside which round and insulate between the 1 to 7 conductor strength. The most common material used for the outside sheet and MIMS cable is the metal. So you can see that also you see that what is the maximum operating temperature of MIS cable. So that will be normally use 100 degrees centigrade, maximum temperature 250 degrees centigrade. How should the MIMS cable be supported? So that we follow the 3.3.2.8 so that measure the undertaken to minimize the damage may include the following. So provision of the support containers as appropriately in the for the mass on the cable. Use all the suitable facing for the cable side and tie that hold the cable in position without damage. Use all the suitable connection for the cable side and tie that reduce the mechanical strain and the joints and termination. Attention to minimum bending radius limit of the cable. Provision of flexibility to accommodate the any moment and tension. It is permissible to use a plastic setter to fix the MIS cable. No, according to the clause of 3.9.7.3. Suppose the adequate protection and protect the damage is also important aspect. So when the termination of the MIS cable to motor, what should provide to stop the vibration? So in this case, we had to use a 3.9.7.3. In this case, we had to use a this loop. By this way, we had to provide the vibration, stop the vibration. It is permissible to install the orange cable body direct on the concrete without any further protection. As I know, this is when we follow the clause of 3.9.7.3. And also the provider with the protection against the abandon of the damage likely to be caused by the manual. So this is the 3.11 also important. Also, are you permitted to use the orange side MIMS cable in the replication room? Answer yes, because of the clause of 5.6.3.2.2, the type permitted. This is across this clause, we can use the MIMS cable in the refrigeration room. So here is a steel wire armors cable construction. This is one of the connection and to the cable gland, and this is the switchboard. So this is the MIMS cable connection to the switch. Here is you can see the pattern holder. So MIMS cable entry to the pattern holder. And this is cable gland. Also the MIMS cable construction. So this is the cable gland construction of the MIMS cable. So metallic metal gland is construction here. So this is can the MIMS cable used for the sheet return system? So answer yes. We follow the clause of 3.16. What else MIMS cable is used for the underground? So the 3.9.7.3 the MIMS cable has combined with the following. So in this case, protection against the corrosion. The type of the MIMS cable shall be selected to suit the environmental condition. It is suited in the wire. The cable is buried in the concrete, plaster, also they install in the underground across with the cross 3.11. Here is a bias rated cable. Here this is junction bulb, a breaking gland. This is the metal cable gland, and this is connection of the metal gland. So this is the construction diagram. This diagram is the physical diagram. This one. This is a physical diagram. The physical diagram. This is circuit drawings are drawings. This is drawing of the MIMS cable. And here is a connection of the clamp. We had to use as a lift. Emergency MIMS cables are utilized for the lift, emergency power system, boiler room, fire pump. Terminations are MIMS cables require the special tool and equipment. The main purpose of termination is associated to prevent the moisture from entering the cable insulation, mixture, and the powder. So this is for the we use MIMS cables connection to the junction bulbs. We also use the general installation tips. They include the expansion, vibration bands are provided to avoid the fracture in saturation where the vibration is better. These are and if the copper wall is hardened, heat to charge and the cooling air. Use the correct tooling roller to remove the band before the installation. Installation assistance is should be the check with the 100 should not be more than the 100 mega ohm. That's with the 50 volt DC. Advantage of the MIMS cable is made of the copper and magnesium. Outside, they are both inert and won't produce any smoke or the gas. Also, the sense strength that they available from the 1 millimeter square to the 400 millimeter square. Largest solid conductor facing wiring is 2.5 millimeter square. So this is for the MIMS cables construction. So this is the electric gas cable below. We can use it as a wiring system underground. As well as the underground wiring system, we use the MIMS cable wiring system. So here is the MIMS cable underground wiring system. So we also use the connection diagram of the MIMS cable. So you have to do this practice. So this is the straight junction box, cable gland, cable, and also the lamp holder. We need the electrician to hacksaw and spanner. Equipments are the SBA cable, cable gland, junction box, batten holder, metallic lamp holder base also included. So this is the electrical trade too. Then we also talking about the workbook. So last week we talking about the G063 workbook. So last week we talking about the phase 180, so that we see as a diagram of the three phase started direct online starter construction diagram. So we can see that the wiring circuit. Also also read as a phase 181. So this is a which should be suitable or which should be not suitable. So this is a automatic closer. The closing system suitable or not suitable. So this is the page 181 table 1. So those are answer on the answers are here. Also we read as an overbody cross 2.7 protection against the overbody, and also the probable cause of the overbody you can see on this one. Those are probable cause of the overbody system. You read the thing. And protection by insulation or separation cross 2.72. You also read it. And this is for the so which items can produce an overbody? So page 183. So this is answer here. Installation on a sub-protection method, we see the cross F1 to 1.2 selection and installation of SPD. So this is the AF3000 F1.2. And also you read this connection diagram. So this is F1.2.2 connection. So this is installation method. Also the cross are 1.2.4, you also read through. Overcurrent protection devices, AF3000, cross appendix 1.2.4, you also read it. And also 1.2.5, connecting conductor, you also read it. And this is for the connection diagram of the such protection equipment connection diagram. So this is the details connection diagram of the sub protection equipment. So those are sub protection equipments are wiring diagram images. You can also study. Those are page 180, 188, 189. Those you can see the sub protection equipment. 190, 191, 192, 193, 194, those are sub protection. Also the page 194 you also see the connection of the sub protection equipment.
So for general English
now we have the connection. This is all the connection of
computer นี่หลุยโชว์ลงนี่ล่ะโชว์ลงนี่ที่มาโชว์ลงเนี่ยแต่อันนี้
body disturbance and the electromagnetic influence. You can also see the 1.5 by 11.3 body disturbance electromagnetic influence. Also the 1 by 2.4 is overcurrent protection devices, and 1 by 2.2 is installation method. And also where the SPD are delivered to switchboard, you can also see it. So connection contactor F1 by 2 by 5, connecting the contactors, you can also read it. Also that you can also see that what is the minimum recommended size for the cable used to connect the SPD and switchboard. So that we also follow this 1 by 2 by 5 connecting connector. You can also see the page 198. And overcurrent protected devices you can see for the page 1 by 4 by 2. So 32 MBR for the 3 MBR SPD, 63 MBR 100 MBR SPD. Minimum working voltage recommended SPD. So you see this cross F1 by 2 by 3. So this is the maximum current is 40 kilo ampere. Volume voltage 275 volt AC to 320 volt AC. What is the maximum charge you want to rest for the cable used to connect the SPD and switchboard? So this is the 300 to the 600 millimeter overall. Not shabby less than 1 meter. This is the cross 1 by 2 by 5. And also that we also see this cross 8 by 3 by 10 operational RCD. Operational RCD, you can see on the place 2 by 8 by 3 by 10. Also the extra low voltage 8 by 3 by 3 by 2. You can also see the cross insulation resistance 8 by 3 by 6. And which connection mandatory to provide a voltage protection. So 2 by 8 by 1 is a cross 2 by 8 by 1. Protection against and corrosion is 2 by 8 by 1 also. 2 by 8 by 1 is a general condition. 2 by 2 by 8 by 2 is a selection of the protected devices. Also the those are the question and answer regarding the protection. So the next one is a protected devices under voltage are the under voltage relay, release operating switch or the circuit breaker and non-latch contactors. Would you be acceptable to use an automatic restarting or replication motor when the supply return to normal after the voltage problem occurs, stopping all the motor? Yes. Answer is. And would it be acceptable to use an automatic restarting or the larger motor wholly enclosed within the ventilation duct? There is a large enough to allow the passing access. When the supply return to normal after the anabolic program has caused the stopping of the motor? Answer is no. So this is for the ASR G0633 protection question and answer. We're talking about the sort of problem in low voltage AC circuit, the trigonometry. So this is the trigonometry, this is the adjacent side, hypervenue, and this is opposite side. So that at the end of this lesson, students should be able to state and supply the sine, cosine, and tangent ratio of the right angle triangle. Use a calculator to find the sine, cosine, and tangent of the any angle. Apply the Pythagoras theorem to right angle triangle. So this is the right angle triangle. This is ABC. Angle ABC. So angle A is as angle CAB is a theta. Angle B is a angle ABC 5. Angle C is a angle BC is a 90 degrees. So this is for the right angle triangle. Side BC is A, side CA B, and side AB is C. So this is the name of the side. So this is A, B, C. You can see the angle theta, angle phi. This one is a hypervenue. This is opposite side. This is adjacent side. So this theta, hypervenue, opposite side, adjacent side. So angles, all the any angles are up to 180 degrees. So this is phi, theta, and 90 degrees, 180 degrees. So the angle A plus angle B plus angle C, the combination is 180, and phi plus theta is 90 degrees. So Pythagoras theorem. So this is angle theta A, B, C here. So that the square of the hypotenuse is equal to the sum of the square on the other two sides. So C square equal to A square plus B square. So here hypotenuse is C, adjacent side is B, opposite side is A. This is the ratio of the side. Sine theta is the opposite by hypotenuse, so that this is A by C. Cos theta is the adjacent side by hypotenuse, so B by C. Tangent theta opposite side by adjacent side, so A by C. So this is the ratio of the side. So that this is the ratio of the side. Sine theta, cos theta, tangent theta equation. So this is the formula. So AE is a what both are example. So this is hypotenuse, the theta is pi, this is 20 meter, 12 meter. So that in this case, theta is cos about 12 by 20, so 53 by 133. This is 53 by 133 is theta is a sine about 12 by 60, so 36 by 87 degree. This is 36 by 8 minus 3. Theta phi equal to 90 minus 53 by 3, so you got 36 by 87. BC is the square root of B 20 square minus 12 square, so you got a 16 millimeter. So that will be the answer here. Hypotenuse and 100 centimeter, 34 millimeter. Theta tangent about 120 by 70 by 34. You got the centimeter by 69 degree. AB is square root of 120 70 square by 34 square, 173 by 37 millimeter. So this angle is this angle 200 millimeter, 160 angle 5. So AC will square root of 200 square minus 160 square, 120 millimeter. So sine B is opposite by hypotenuse, so you got the 120 by 200 by 6. Cos beta is adjacent side by the hypotenuse, so there will be 160 by 200, you got by. Tangent beta opposite by adjacent side, so 120 by 160, you got a 0.75. So the sine C is opposite by hypotenuse, so there will be 160 by 200, 0.8. Cos C is adjacent by hypotenuse, so the 120 by 200 is 0.6. Tangent C is opposite by adjacent side, 160 by 120, 1 by 3 degree. So that will be there's 0, 90, 270, 180 degrees, so this 0 degree here. Then rotate it, this is plus 30 degree. Sine 30.5, cos 30.86, tangent 30.577. So this will engage at 150 degree. So that this is the so sine 150.5, cos 150 is minus 0.86, tangent 150 minus 0.577. This angle is 270 degree. So that will be the sine 150 minus this is minus 150 is a minus 0.5, cos minus 150 is a minus 0.86, tangent minus 150 is a 0.577. The angle is minus 30 degree. So sine minus 30 is minus 0.5, cos minus 30 is 0.86, tangent minus 30 is minus 0.577. So this is the both things are relationship. You can see the sine 30, sine 50, 150, sine 220, sine 330, we can put on this diagram. This is all sine, tan, cos. Because all angles are positive, EI is sine are positive, others are negative. This quadrant, tangent is a positive, others are negative. This quadrant, cosine is positive, others are negative. So this is the angles are 10 degree, 20 degree, 70 degree, low angle theta. We can find the sine, cosine, tangent, and the tangent angle. So those are angle value, you can read the table. Then you can do the problem exercise. Then we also talk about the alternating currents are quantities, AC quantity. So the problem in low voltage AC circuit, alternating current quantity. At the end of this lesson, students should be able to define the terms of alternating current and disadvantages, identify the basic weight shape and the list used for each. Second, the simple sine wave and show the P2P and the RMS value as well as the period of the wave, calculate the value associated with the AC waveform, and also to define the stress and the form factor for AC waveform. So this is the common waveform diagram. This is for the square wave. This is for the sawtooth wave. This is a triangular wave. This is San user way. So this is general operations. This is a normal and solve electric magnetic power flowing and the conductor moving. So A to B. When the conductor moving here, the vertically, that will be VAB, rotate AB. And when the rotor rotate this way, so the from in the magnetic field, the conductor will go rotating like this way. And conductor rotate this way, the current flow here, waveform here. So now this diagram, waveform and the current flow. Then this diagram, waveform and the current flow. And then this one will be a complete one cycle. The alternating current is like this. This is output generator is alternating. The voltage will be 0 to minus 90 and plus 90 like this. Alternating current quantity. So the average value of AC quantity is 0. Amplitude between the P of the AC quantity known as the P to P value. So this P to this P, the P to P. The half of the P to P value is now the peak of the maximum value. So PP is a peak of maximum value. VP to P is 2 VP. And the root mean square value of the AC quantity, the equivalent value to DC value, that would do the same work. So VP is the square root of 2 are the RMS. The time taken to complete the one cycle on 360 degree is a period T. So this is a period T. So this is a period T. This is a period T. The frequency half of the waveform is the number of cycles per second. So F equal to 1 by T, T equal to 1 by F. Any size of the waveform can be described mathematically by VD equal to VB sine 360 ft or the VB sine 360 T by T. Where the VD is the instantaneous value of the sine wave, T is the instantaneous time, VB is the peak value of the wave, F is the frequency of the wave, F equal to 1 by T. 360 Ft is the angle of the instantaneous time T. Every value of the mathematical AC quantity is 0. So every value that rectified AC quantity is 2 by 5 or 0.637. The form factor AC waveform is the form factor VRMS or V average. So the pi by 2 to 2, you got the 1 by 1 1. The crest factor AC waveform, the crest factor V maximum VRMS is root 2 or 1 by 414. And then you do the problem exercise. Those are the advanced associate degree. I only talking about the trade 1, trade 2, also the AC quantity, so G1 or 2. So this is Bachelor of Applied Engineering. Then you also have to do the advanced diploma electrical. So we go to the site. The Bachelor of Applied Engineering. So the Bureau of Engineering College of ADB Energy Electrical Electronic Resources 1 or 80. Click this one. And then we have to find the electrical diploma 2022. Go through electrical diploma 2022. So the IUI College of Select Electrical Diploma 2022.8. Click this one. Then you find out the Electrical Diploma 2022. Then you see the YouTube video for electrical engineering lesson. Click this one. So the direct link is the IUI College of Select Electrical Diploma 2022 Study Option 3.8. So this link is a click to the lesson. After you got a lesson, last week we have already finished the E1 to 6. Now it's we continue. G071 electrical contracting specification. So the lesson notes are the electrical comprising the project management. So we create the highlight computer.com/video lesson.pdf and page 1022 to 127. Those are the slides. Those are video. Those video you have to read view the video, and their notes are written notes are here. So E071, G069 is G70, lesson 1 to the 70, you view the video. Those video written notes are here. So page 102 to 120. So this is the page 102. You see the project management planning up to the page 120. You can see the organization management, project management, analyzing all the plan. Those video you can read through. And then you see the project life cycle, project cost, preparation, also the electrical installation, change all the control, and preparation manual, also the development management thinking, and also the trade-off in project management, planning, consulting, goal, and also the modeling of the project system. Those you can see on the lesson.